Okay, so today what we're going to do is we're going to talk about standard form of a linear equation. Now, you've seen things in other forms in pre-algebra, primarily slope-intercept form. This is another form. We're going to really talk about this one and kind of get into it. So standard form is this: ax plus by equals c. And it's where a is greater than or equal to 0. A and B are not both 0, not both 0. One of them can be 0, but not both. And A, B, and C are integers. Now, this is kind of like the example of what you'll see when you see it. 2x plus 3y equals 5. Right here is going to be your A. Right here is going to be your B. And 5 is your C. This is your constant. This one's not going to change. Once you have that one, it's going to be there. And these two change based on what you put in for y. Okay, so that's kind of what you're looking at here. Now, this form is really useful when you're trying to find your x and y intercepts, and we'll talk about that tomorrow. We'll go into it on how you actually can do that. So this form has a use. What I need for you today is to be able to actually take and change any type of equation and put it into standard form. So that's what we're going to be looking at today. Why? And we just got a couple examples here. We're going to go into it, show you how to change it into standard form. So y equals 4 minus 3x. Now, we want to move everything over so that it looks like this form right here. ax plus by equals c. That's what we want it to look like. So in order to get this y equals 4 minus 3x to look like what we had over here, we need to move this to this other side here. So what we'll end up doing is we'll end up adding 3x to both sides. Just like you've done everything in all your equations up to this time, when you do one thing to one side, you do it to the other to maintain that balance on your equation. So add 3x, add 3x. Okay? And that cancels this out, gets rid of that, and it leaves us with the 4 over here. Okay? Equals. There's our constant, our 4. And then normally what we would do is we'd go, well, y plus 3x. But that's not what we want. We want the x in front of the y. So we're going to take this and move it in front. 3x plus y equals 4. Now, here's your a, here's your x. You have a b there. It's just that invisible 1 that's always there. Right? And then you have your y and you have your constant. 3x plus y equals 4. And this is a good standard form. Okay? Yeah, that's what you're looking at. Now look, you have negative 5x equals 15 minus 3y. All right, so we want to take and we want to move this to this side. Okay? Add 3y, add 3y. Okay, and you end up with negative 5x plus 3y equals 15. Okay, now we have a problem here. We got a negative 5. But over here in our definition, a is greater than or equal to 0. Well, negative 5 is not greater than 0. So we got to get this where it's positive. So what we're going to do is we're going to multiply through by a negative 1. Okay, so this side all multiplied by 1, and this side multiplied by a negative 1. So this is going to change your signs inside of this. So distributive property, negative 1 times negative 5 becomes 5x plus negative 1 times 3y, negative 3y equals, and 15 times negative 1 gets you negative 15. Okay? That's what we're looking at here. Okay? Pay attention, understand what's going on when you're doing this. But I mean, we want it to be a positive, it can be 5x plus negative 3y equals negative 15. This is what you should be looking for, okay? All right, and it'll come into play later on when we do slope-intercept form like that again, and a few other forms. So be understanding what that is. All right, so 9y equals negative 3x plus 6x. Same situation, move the 6x over here. So add the inverse plus negative 6x, okay? That gets us negative 6x plus 9y equals negative 36. All right, so again, we could multiply through by a negative, but there's also something else we could do here. We could actually reduce this down. See how each number is divisible by 3? So we could go in there and we could reduce this down to its simplest form. We want to be able to do that. We need to be able to do that. So what we're going to do is we're going to divide each one of these by a negative 3, and that'll change that sign of this negative 6x. So divide by negative 3, divide by negative 3, divide by negative 3. And we're hitting each term in there. And we're using 3 here because each one of these are divisible by 3. And we're using a negative in order to turn this into a positive. Because a negative divided by negative gets you a positive. So that's why we're using this, because each one is divisible by 3, and we're using the negative to turn the first part here into a positive. So we get 2x plus negative 3y equals a positive 12. And now, see how that's in its simplest form now? Now that comes into play also again in other things that we do, but we want this to be in our simplest form. So if something can divide evenly into each one of our terms, we want to make sure to do that so we have it in its simplest form. 2x plus negative 3y equals 12. You could also write this like this, 2x minus 3y equals 12. Those two things are the same thing. You need to be able to recognize that those are the same. Again, it's in standard form. Here's your a, here's your x, here's your b, here's your y, and here's your c, your constant. And that's what you should be looking for. All right? Now, this problem right here. And we have a lot of problems just so that you can kind of see how things get manipulated into standard form. 1 minus 3/10 x equals negative 1 over 20y. Guys, clear your fraction. Let's get rid of them. We don't want them if we don't have to have them. So we're going to multiply each term by 20. Now, you can do that before, you can do that after. I suggest getting rid of those fractions as soon as possible. So that's what we're going to do. Multiply by 20, multiplied by 20, multiplied by 20. And I use 20 because it's the common denominator. 20, 10, and 1, so I can use 20 all the way through there. So that gets you 20 minus, and here goes over 1, cross cancel, becomes 2, gets you 6x equals, cross cancels, gets you negative 1y. All right, so here's what I'm going to do. I'm actually going to move this to this side. Okay, so add 6x to both sides. Okay, and what that leaves me here is this 20 equals 6x, either plus a negative y or minus y, either way, minus y. But this is not in standard form, it's reversed. So you can take the whole of this side and the whole of this side and switch them, okay? 6x minus y equals 20, and I believe it's called the reflective property. Is it symmetric property? I don't know, I forget them, but just understand that you can take the whole of one side and the whole of the other and you can switch them, okay? If you can remember that, you're gonna be okay, because it's more important that you can use them than it is to be able to identify them. I'd rather you know how to use it, okay? So 6x minus y equals 20, all right? And then, is it reduced? Yes. Is that greater than 0? Yes. All right, so we're good, okay? And we keep going. Now look, 0 equals negative 3y minus 15 minus 27. All right, so let's move everything to the left side that has the variables. Everything that we want over the side, the y's and the x's, all on that side. Okay, so add 3y. Add 3y. Okay, so that gets you 3y equals negative 15 minus 27x. Well, now let's add 27x to both sides, plus 27x. Okay, that leaves you with negative 15 equals 27x plus 3y here. But if you look at it, 27, 3, and 15 are all divisible by 3. So we get to reduce again. So we're going to divide each term by 3. Well, that gets you 9x plus 3 divided by 3 gets you 1, or just the y left over, equals negative 5. You have to be able to do this right here, or you can reduce this. We want it in its simplest form. That's what you're looking at. All right? So now, 3 equals y. And you're looking at it going, wait, there's no x. How do I put that in standard form when there's no x? Well, if you think about it for a moment, any number times 0 gets you 0. That's something we're going to use right in here. So 3 equals y. I'm going to reverse this. Y equals 3. But this is in standard form. Because what you really have is this 0x plus y equals 3. See how this and this are really the same thing. 0x, and in our definition it said that one of them can be 0 but not both. So 0x, your a here is 0, your b is 1. That's how you get to this. So this is a good number for in standard form. You just have to recognize it when you see it. Same thing here. X equals 5, no problem. X plus 0y equals 5. And if you have to write it like this, fine. Just so that you can see it. But understand that these two things, they're both in standard form. This is how we normally write it. But if you need this to understand what's going on, fine, do that. Okay? Be careful, your teacher may not accept this. They may say, no, 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 this is the right way, and they're correct. This is the right way. But understand this and this, they're equivalent. They're the same thing. All right? So if you need help getting your equations into standard form, let me know. I'll be here.